Okay, so question number 21A, given the following quadratic function, find the zeros. So we look at this, we know that it is in standard form. X has a coefficient of 1, so all we really need to do is find our factors of negative 18. So maybe 1, negative 1, 18, negative 2, and 9. Negative 3 and 6, and this looks like it would add up to positive 3 in the middle. So we set up our factors here, and we are going to say x minus 3 and x minus 6. Okay? Then you set each of those factors equal to 0, and solve for the zeros. So then we have x equals 3 and x equals negative 6. And when you write your zeros down, make sure that you use these type of brackets so that you do not, so nobody thinks that it's an ordered pair. Okay? And for 21B, again, we know that we have a coefficient of, oh, I'm not recording. Shit. Okay. All right. So in 21A, I've written out here how to find these zeros. This is in quadratic formula, so we have a coefficient of 1 right here, so all I need to do is just find my factors of negative 18 that will add up to positive 3 in the middle, and we would have x minus 3 times x plus 6, okay, and if we did the multiplication, we would have x squared minus 3x plus 6x, and we would end up with our formula here. You take your factors, you will set them equal to 0, and then find them. So x minus 3 equals 0, and x plus 6 equals 0. So our zeros end up being x equals 3 and x minus 6, and you write them down right here. Okay, again, for B, we have a coefficient of 1 in front of our x squared. So what we really need to do is just find our factors of 45, and that would add up to negative 14. So I think it would be negative 9 and negative 5. Negative 9 times negative 5 is positive 45, and they add up to negative 14. Okay, so we've got our factors here. We set each to equal to 0, and that would give us x equals 5 and x minus 9 equals 0, and that would be x equals 9. So our factors are 9 and 5. Okay, so going on to question 22, find the vertex and determine if it is a maximum or a minimum. Oh, I'm not recording. So first of all, we can decide by looking at the leading coefficient on our x squared that this is going to be a maximum. The parabola will be upside down, like this, and your vertex is going to be at the top. Okay, you can tell that by the negative coefficient. So the next thing that we need to do is we need to find out what our vertex is. Since this is in standard form, we will find x, okay, by using opposite b over 2a, okay? And opposite b would be 2 over 2 times negative 1, okay? That tells us that x equals negative 1. All right? Because we have 2 over negative 2, and x will be equal to negative 1. So we have our first component of our vertex, all right? And then we put this back in to the equation, okay? Okay, oops, sorry. Okay, and if we calculate this, we will find that our y is negative 4. Okay, so by entering x back into here, that will tell us what y is. All right, in 22b, again, we need to do opposite b over 2a, so that would give us negative 10 over 2 times 1, all right? So we know that our x is going to be negative 5, all right? And if we put negative 5 back in for x to find y, that would give us negative 1. Also, to finish up with 22b, we know that this is going to be a minimum. If we were to put this in our calculator and graph it, our parabola would look like this. So our vertex would be at the bottom right here. There's a positive coefficient in front of the x squared, so that tells us that this would be a minimum. Okay, 23a, given the quadratic functions, find the domain and range for each. These are in vertex form, so we just need to find the range, okay, and we can tell by looking at this component right here that is outside of our quadratic form, okay. It is negative. There's a positive coefficient in front of our quadratic form, so we know that everything is going, the parabola will be like this. Okay, so everything above negative 4 will be included in our range. So we say y is greater than or equal to negative 4, and the domain is all real numbers. Okay, in this, it's in vertex form, so we can look at this. This tells us where our range will be. Everything is going to be less than or equal to negative 1 for the range. Okay, and we could tell that our parabola will open up downward, So everything below -1 will be included in our range, and our domain is all real numbers. Okay. Okay, for 24A, find the axis of symmetry for the graph of the parabolas. We look inside the quadratic term, and we take the opposite, okay? And it's going to be x is -3, okay? So that would tell me on my graph I would have my x term would be -3 right here, okay? All right, again, for B, we are in vertex form, so we just look inside the quadratic term, and we say that we go the opposite of 6, so x equals 6, okay? Our parabola is going to open up like this, and we would have 6 would run through the middle, would be our axis of symmetry. Okay. 25, how would the width of the graph of the function f of x equals 2x squared minus 1 change if the 2 were replaced with 1/2? If you were to put this in your calculator and use the graph function, you would find that the graph would become a lot wider. It would go from skinny, this would be 2x squared minus 1, where half x squared minus 1 would look more like this. And finally B, how would the width of the graph of a function f of x 2x squared minus 1 change if the minus sign was changed to a plus? Okay, so we're talking about this minus sign right here. There would be no change. The change has to do with the coefficient in front of the x squared. So that one would be no change. Where's my paper? Thank you. Like an idiot. Okay, so. How do I save this? I forget. I'm sorry. What is that? How do I save this?
You know, I did it, everyone's been doing it differently. I've only done it this one
this is
So,
done, so.
is it over here?
No, this is the last one I did.
I would
did
wait
two.
till it shows up over there.
It's not showing up, so am I doing something wrong, or?